Hi and welcome to the presentation for the upgrade of the R33 section 13 in VAALWATER, Limpopo. So let's get into it. So first up, the agenda. So I'll be doing introduction and welcoming. Then I'll give a bit of a project description. Then explain some of the existing infrastructure, the design process that I followed, and then we'll head into some conclusions. So introduction and welcoming. This project was part of the transportation, geometric, and pavement design project for the semester, and it is to upgrade an existing road that has reached its life end. So a bit more of the project description. As previously mentioned, the road is situated with, or rather it runs adjacent or parallel to the VAALWATER community, which is in the Limpopo province, and the road has reached its life expectancy, and therefore we've been tasked to do a design for the upgrade of the road. And the total length of the road, or rather, sorry about that. The total length of the road is a couple of kilometers. However, we'll only be focusing on roughly 2 to 3 kilometers, which is the length of the VAALWATER community. So the topography of the area is relatively flat. So that means that there won't be much cut-off volumes within that area because of the corridor template. Then the climate in the area, Limpopo is known to be a very hot and dry province. So the winters can get humid and they'll have very dry summers. Then geology, based on the information given, it appears that the soil ground conditions are very clayey. That means that the soil is very susceptible to moisture content. So that would be taken into account when dealing with the pavement structure. So as for existing infrastructure within the project area, as we've been provided with the information, you can see that the road verge has some drainage elements beside it. You can also see that there are some heavy vehicles making use of the road, and they often park on the road shoulder, which is gravel as well. So if we look at the total road footprint, we have a surfaced road and then gravel shoulders. Then on the right, just some of the existing drainage structures within the project area. And as shown in the image, you can see that the area, or rather the culverts, are susceptible to silt as well, because as previously mentioned, the soil conditions are quite clay. So it can be assumed that due to that there's lots of movement in the soil, etc. Hence why the culverts are quite filled with silt, and that can also be due to maintenance issues. So heading into the design process, we were also given some terrain data and survey data. So based on that, it was then quite straightforward to make use of the Open Roads designer software, and then using your geometry tools, complex by PI, to then create your or rather my horizontal alignment as well as my vertical alignment, and applying SUNRAL and the TRH standards to ensure that the that the alignment data is, or rather complies with the standards, so that we know that the design would be satisfactory upon completion and for construction. Further into the design process, we were requested to do a dual carriageway, a divided dual carriageway with sidewalks as well, because it has been noted that there are quite numerous amount of pedestrians that crosses the roadway. So just providing that NMT facility to making it much safer for the pedestrians as well. And also during the carriageway, the traffic volumes in that area is quite large, as well as numerous or a large amount of heavy vehicles making use of that road. So during this carriageway seems like the best option to accommodate the future traffic volumes, as well as the heavy vehicles making use of the road. As you can see, there is quite a large rolled shoulder, surfaced rolled shoulder, and also providing an embayment, an embayment further down, for them to also use as a rest area. Then looking at cut and fill volumes, there's quite a bit of cut due to the cross section being so large and not that much fill volume. So this actually works in our favor, as that cut volumes can then be discarded, and if the material is of good use, it can then be used as some of the fill as well, so that importing materials and so on wouldn't be that great or expensive. Then further on, with regards to drainage and services, all services will be relocated accordingly as the whole roadway and footprint gets bigger, as well as drainage. So having that drainage point in the middle of the corridor, as well as channels on the side for water runoff, and then just making use of the existing culverts but upgrading them so a bit bigger, so that they can accommodate more as the road surface is bigger, so therefore there would be more water runoff. So just having those elements in there would allow for a better drainage system within the corridor. And I have touched on the services that will be relocated accordingly. So that is also your electrical lines, your telecom lines, street lighting will be provided as well. Since VAALWATER is a small community, but we have many people or vehicles and motorists passing by. So that would be attended to as well. In terms of environmental, this would have a positive impact on the community, because as I said, there are a lot of motorists passing by the area. So therefore, having this upgrade, it only benefits both motorists, NMT users, as well as the community, having that done. And then visual impacts, some trees or some gardenings and stuff, just to lessen the visual impact a bit, so that it's not such a sore eye. And I think that is all for the design process. Then heading into conclusion, as I've mentioned, both motorists and NMT users have been accommodated for, and that the design meets all the design standards and requirements for the class of road, which is a class 1 road. And the pavement, which is suitable for heavy vehicles, So having your asphalt layers and your concrete layers as well, um, which will then ensure that it will have a decent next life expectancy of another 20-30 years. And that is all. Thank you very much for listening to my presentation.